Okay, we are off on 4-4 day 3, and this is all about our page 9 in our packet. So we're page 9 in the packet, and we're looking at page 9, and we're talking about the K value, our vertical shift. If positive, it move up. If negative, it moves down. And let's get that cursor back in here. So if it's positive, move up. If negative, move down. Think of moving the x-axis up or down the graph. Now, the graph will now oscillate about the line y equal k, a sinusoid axis. So now the horizontal line that k defines is going to be our new axis. Now, the range of the sinusoid in the standard transformation form, y equals a sine b of x minus h plus k, or y equals a cosine b times x minus h plus k, is given by k minus the absolute value of a, or k plus the absolute value. So we're talking about the range itself of the graph. Let's just fix that. Guess we can't. Okay. And now we're off to example 8. Determine the amplitude, period, phase shift, and the vertical shift. Then find the range and graph each of the following. Okay, so we got a few things to find here, so let's just be patient and talk about what we got to do first. Okay, as we go, we're supposed to go the amplitude. A is equal to 4. Okay, now the next thing is period, but we get our period from B, the absolute value of B, and B is located right here at the 3, okay, in that position, so that's 3. And the phase shift, well, we're still on period. And P is equal to 2 pi divided by 3, so that's our period, 2 pi over 3. Now remember, we have 5 critical points. Our 5 critical points will be separated, separated by 2 pi over 3 divided by 4. So 2 pi over 3 will give, divided by 4 will give me pi over 6. Okay, remember that's going to be 2 and that'll be a 6 in the bottom. So pi over 6 will be separation of my critical pieces. But remember, when I'm working with sine, sine is less than or equal to 3x, less than or equal to 2 pi. Okay. And now I divide by 3, and I've got 0 is less than or equal to x, which is less than or equal to 2 pi over 3. So it's really nice. It's going to start at 0. We're going to go up by pi over 6, and we're going to get to 2 pi over 3. So our numbers are going to be kind of interesting here as I separate this out for my graph that I'm going to be working with. As we talk about this, let's see what we've got. We're first going to do negative pi over 6, and we're going to go up every 2. So I'll have here negative pi over 6. And then I'll have 0, pi over 6, pi over 3, or 2 pi over 6. I'm going to stay with pi over 6s so it's easier to break it up. And you can see that I'm going up by pi over 6. Now I got 3 pi over 6, which is the same as pi over 2. I got 4 pi over 6. And then I got 5 pi over 6. And 6 pi over 6 are just pi. 6 pi over 6 are just pi. But remember, my graph will repeat itself starting at 2 pi over 3, which is starting right here at this point. So at 2 pi over 3, it'll start repeating itself. And we're going to undo that real quick. So I've got our grid down. Our 5 critical points are going to be, by the way, the 5 critical points we're looking at are 0, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So these are the 5. 1, 2, 3, 4, 5. And went up by pi over 6 from 0, and it encompasses this because 2 pi over 3, that's 4 pi over 6, is the same. Okay, now keep in mind we're looking at sine, so it's Sahala. Okay, so when I'm looking at sine, if I'm going to graph it, let's get a different thing here. For sine, I go axis, high, axis, low, axis. So that's what we're going to be going on, and that's where I'm coming back from. Now, keep in mind, as we're doing this, after we get all this set up, and I've got these nice points and everything, you're thinking, do I have any other axis other than the y-axis to work on? And when I look at my numbers I've got up there, I'm looking at the fact that I've got that 2. So k is a value, and that says -2. So down here at -2, we're going to have my axis symmetry here. Okay, so right here, we're going to come across, I've got an axis coming across at y equal -2, y equal -2. Okay, and that's where my axis of symmetry of my sinusoid will be. And now that's where I start all my plotting. So I'm going to start plotting with blue. It's sine, so it's on the axis at 0. And then I go pi over 6, I go high, and I go 4 high, so it's 1, 2, 3, 4 above my axis of symmetry, back to the axis, 4 below my axis of symmetry, 1, 2, 3, 4, 1, 2, 3, 4, and then back to my axis, and 4 above my axis of symmetry, 1, 2, 3, 4, and back to the axis of symmetry. So now when I'm checking out my graph, I'm going up, up, coming down, coming back up to the axis, coming back, and we're there, getting our sine curve on. And now we are asked to find a couple other things here. We're supposed to find range, and this is where we get the opportunity to find our range. Our range is actually down here at 1, 2, 3, 4, 5, 6. From -6, down here, -6, okay, and up here at +2. So my range is -6 to 2. Now keep in mind my domain on this, and perhaps I should have done that first, is all real numbers, or -infinity to infinity, because it's continuous all the way along its domain. Okay, so those are the things I'm looking at for my steps. My critical values are pi over 6 apart. Okay, remember, pi over 6 apart. That's why we go 0, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. That jams with this, just to make sure I know my starting spot, I know my ending spot, and then I get to fill in on either side of that as I graph. Now we're going to do the same thing here, coming up in B, on 3 sine 2x minus pi over 2. But now, when I do this one, you got to keep in mind, I've got to factor out the b, okay? So when I'm taking care of this, we're going to pull my cursor back up. I got to factor that 2 out, okay? So I'm going to rewrite this function, and it's y equals 3 sine, I'm factoring out a 2, x minus pi over 4. So I'm going to have a pi over 4 shift, okay, to the right. But we're going to double check that shift with checking it out this way. 2x minus pi over 4 less than 2 pi. Remember, this is the general length of our function for a sinusoid, sine and cosine. And I'm just going to solve for x. So I'm going to divide by 2, 0 less than or equal to x minus pi over 4 less than or equal to pi. Now I'm going to add pi over 4 to all sides. So adding pi over 4 to all sides gives me 5 pi over 4 over here. So I'm going to start at pi over 4 and go to 5 pi over 4. And I just found out my period's 1 pi big. But let's just double check that, because it's always nice to make sure I can guarantee that that's what it's going to be in a couple spots. First, absolute value of A is 3. Absolute value of B is 2. Now my period, keep in mind, is 2 pi divided by b, the absolute value, which is just going to be pi here because b is 2. So we've got that set up, and we can find the numbers that we're going to count by dividing our pi by 4. So our critical values are going to be, starting at pi over 4, and we're going to go up by pi over 4s. So I got pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. Okay, well, keep in mind, that jams with this, that jams with that. If you want, you can totally reduce. This is going to be pi over 2, and this is going to be, should be 4 pi over 4. This is going to be pi. So if you'd like, you can have those reduced as you go through. And we're just going to plot those values down. I got 0, pi over 4. Let me get my cursor down here. I got 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. And I got some spill out just to like make sure I got my graph taken care of. Now, I'm going to go up and check my k. I got k minus is a minus 1. So my axis of symmetry here is going to go along at y equal -1. So y equal -1 is my axis of symmetry. So that's the axis I'm going to come back to. But now this time I also have a horizontal. I have a horizontal shift that starts at pi over 4. So I'm going to have something that starts right here, and this is where we start. Okay. So now I'm going to get a red marker and put this in. So at pi over 4, since it's sine, okay, again, it's sine, so it's sine is axis high, axis low, axis. So keep in mind that's what Sahala is. It kind of is a short memory thing to help me with that. And now I've got Sahala going through here, and I am looking at starting on my axis at pi over 4 at 0. Now I'm going to go high, and my high is 3. I've got a 3 there for my amplitude, excuse me. And so it's 1, 2, 3, away from my axis. Now keep that in mind. It's away from my axis that 3 exists. Back to the axis, and then I go down below the axis 3, and back to the axis and above the axis 3. And I can go back and fill in the other spots here. I was back at the axis. I'm going to be low, 1, 2, 3, and I'm back at the axis here. So if I put myself in position to draw my curve and get this so it makes most sense, I got my sine curve going through there in the red. Okay, and again, I'm supposed to find my range. Now again, the domain here, domain is -infinity to infinity. My range is 1, 2, 3, 4, -4 to +2. Now I'm hoping that you're recognizing that range is the amplitude and my axis. So it's my axis plus my amplitude, and my axis minus my amplitude. Okay, so the low side of the range is my axis minus my amplitude, -4. High side of the range is my axis plus my amplitude, +2. Now again, as we do these, each one very similar to the other one, we find our original points. We got A is 3. We got B is 2. We're going to get the period, which is 2 pi divided by our B, which is pi. Okay, 5 critical points. 5 critical points. Okay, so they're going to be separated by pi over 4 because it's our period divided by 4. Let's so find out where they're going to start. 0 less than or equal to 2x less than or equal to 2 pi. Now divide by 2, and 0 is less than or equal to x, which is less than or equal to pi. So it's me from 0 to pi. So my critical points are going to be 0, pi over 4, pi over 2, the one up by pi over 4 is 3 pi over 4, and pi. Okay, so I'm going to get those graphed on my chart here as I go down. And I'm going to separate this out. I'm going to go up by 2's for my pi over 4, pi over 4, pi over 2. Remember, that's the same as 2 pi over 4. I got 3 pi over 4, pi, 5 pi over 4, and now I got 6 pi over 4, which is 3 pi over 2. And I get back here my negative pi over 4. Okay, now again, I'm looking back at my grid. I got a shift down -1 for my axis. I start at 0. Okay, now I'm going to graph Chala, cosine, it's high, axis, low, axis, high as I go through and get my cosine graph. And I start here and I go up, checking my amplitude, go up 3. 1, 2, 3. I start high. I go to my axis. Okay, starting high, go to my axis, go low. 1, 2, 3. Back to my axis. Back high. 1, 2, 3. Back to my axis. Low. 1, 2, 3. And now I put myself in position to draw my curve. Try to get it going here. And that's my cosine curve. And I look at my range. I don't have really a pretty drawing here, do I? But I look at my range. 1, 2, 3, 4. So it's down here at -4. 1, 2, 3, -4. I'm up here at 2. Okay. So my range, my domain, first of all, is from -infinity to infinity. And my range is from -4 to 2. Because it's going to oscillate back and forth. Okay. Now, we've got another cosine as we're going along here. And we are looking at reading A, which is 1. We're reading our B, which is also 1. But now we got a phase shift inside. So we've got a period that we're going to make a little bit of adjustment with maybe, but not really, because we got 2 pi divided by 1. It's 2 pi. And our 5 critical points are separated by pi over 2. Okay, so now let's check out where those points start. So I've got 0, it's less than or equal to x minus pi, which is less than or equal to 2 pi. Well, I'm going to add pi to all 3 things, and I get at 3 pi. Now, I'm going to go up by pi over 2's. Every 2 is going to be a pi over 2. So I got pi over 2. Well, here, if I can move that over. I got pi over 2. And I've got here at pi, and I got 3 pi over 2, and 2 pi, and I've got my 5 pi over 2, and 6 pi over 2, or 3 pi. So you got to keep in mind, those are my critical points as I'm going on here, because I've got a shift that starts at pi, and so I've got my pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. Excuse me. And 3 pi. Okay, so now I've got my 5 points, 1, 2, 3, 4, 5. Those are my 5 critical points. So I've got a shift in my graph. Let's get us a nice change in our axis so we can see where it's going to go. I've got a shift to the right, and we could predict that it was a pi shift to the right. Okay, and then it's a shift down of my graph, my axis of my graph, at y equal -1. So I've got an axis of y equal -1, and I've got a vertical shift, or a horizontal shift, I should say, along this vertical line here. Okay, at negative, since I'm subtracting pi, it's pi. Now, that's where I'm going to start. I'm doing cosine, so it's chala again. So cosine, high, axis, low, axis, high. So it's 1, 2, 3, 4, 5 as I go through. Now, grab a different color. We're grabbing blue. We got 1, so I'm just going to spread out my stuff here a little bit. Every 2 is going to be, so if every 2, we're going to adjust that down if that's going to be 1. That's be my -1. Okay, so I decided to move that down there. So now this is -2. This is +1. That's +2. So I can see more of my graph. Now, looking at this, and I'm going to be looking, yep, got that -1, got that over here. I'm going up 1 to start things out. So I'm high, I go to axis, I go low, remember this is at 1, I'm going by 2's, go in the axis, and high. And back here, axis, low, axis. So as I go, I got my graph going across, and I got my cosine graph with my axis at -1. I did units, every 2 units is 1, okay? And now I've got my domain, which is from -infinity to infinity. I got my range, okay? My range, remember 1, 2, so it's at -2 to 0. And I could have predicted that beforehand because it's, taking -1, adding my amplitude, that's my high, and taking my -1, subtracting my amplitude is my low. Okay, so I've got those, and that is the graphs that we have sitting there on page 9. Okay. Now, as we're going on with the next ones, keep in mind, not all of our B values are going to be positive. So let's learn about that. When B is a negative value in standard transformation form, okay, let me get my cursor back in there so we can all see what I'm doing as I go in. Standard transformation form, use the fact that sine is an odd function. Remember, sine is odd. So when I have an odd function, the opposite of x is the same as taking the opposite of the entire function. If I put that -x in, it's the same as this. So when I do this with sine, what happens here, if I have a negative b value, I can bring that out, and now it's about that negative sign goes with the amplitude, and it doesn't affect the b. Okay, that's how I will deal with reflecting across the y-axis. I will pass it on to the x-axis. Okay, now as a cosine is an even function, to simplify the equation prior to graphing, okay, so if it's an even function, check out what happens. Since the opposite of x is equal to f of x, and it's cosine, since it's an even function, if there's a negative value inside, I treat it like it never existed inside. Remember, this is all about the b value being negative. So using these properties will avoid physically reflecting graphs across the y-axis, which is a pretty big bonus when you really think about how complicated your thoughts could be with a sine cosine graph, and it really simplifies the whole situation for us. So let's look at this first situation in example 9. Determine amplitude, period, phase shift, and vertical shift. Then find the range and graph each of the following. So we're going to do amplitude as we go through, and period and everything, but let's rewrite it. Notice please that we took out this -2. Okay, I factored it out, and that negative factored out here. And just to practice, it's -2x, that's that. Negative pi over 4, which would be negative pi over 2 as I reduce. Why am I doing this is because b has to be separate from the rest of the terms inside here. Now I've got a negative b. And we just learned that when we have a negative b, we can pass that negative to the amplitude term. Well, the a term has that -3, excuse me. So now I can rewrite this, since it is a sine, since sine is an odd function, since this is something I know, I can rewrite this and have it be this. Notice that these are the same here, but that negative on the 2 was shared here with the a term, and now that negative a term is no longer there, it's positive a. Okay, so now I can read everything correctly using the idea of odd functions. And this is the expectation that we learn this, and this is how we deal with negative b values inside. Okay, so now if we can get this to come down, so we've got determine amplitude. Well, let's go get our amplitude. It's 3. Okay, determine our period. Okay, well, our period with our b is going to be pi. Okay, so we got pi as our period. Our phase shift. Okay, well, we got a shift here. We got a negative pi over 4 shift, but let's talk about how that was arrived at. We take this value inside. Okay, this value I'm going to divide by 2. Okay, all the way across, so I'm dividing by 2, and that's 2 pi there. And now I'm going to subtract pi over 4. So I'm going to subtract that pi over 4, and I got this going on with x by itself, so I'm going to shift it to the left, and we'd expect it shift to the left the way it's written there. I'm going to shift it to the left, and I'm going to actually shift it down 3 units as well. So now we got our pi over 4 is our spacing, but now we're going to shift it pi over 4, and we're going to go up pi over 4. So our critical points, if I can actually bring down. Okay, so let's redo this. And we got our critical spacing going on here. We got pi over 2, 3 pi over 4. So let's go up by 2s, and I got my negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, 4 pi over 4, or pi, 5 pi over 4, should be pi over 4, and now I got 6 pi over 4, which is 3 pi over 2. Okay, so now we've got our critical points and then some extra stuff to see what the graph will look like. And now keep in mind, we're going to start with our axis at -3. Okay, so we got our little axis at -3. So we're going to pull this down. We're going to go down to 3. 1, 2, 3. That'll be our axis right there, -3. Okay, y equals -3. Okay, now keep in mind, push that over there, that's our horizontal line. And now we've got our axis of symmetry for our function. It's got an amplitude of 3. It's actually sine, and we got a pi over 4 kicked back. So we are going to start back here. And we are graphing sine, so it's Sahala. Whoops. Axis, low axis. Someone's got to be able to write this incorrectly. Thinking about the next one, I'm not even keeping track. So we start on the axis, we go high, we go back to the axis, we go low, we go back to the axis. Okay, so now, starting on the axis, let's get a different color. I'll graph my points in blue. We start on the axis. Okay, remember pi over 4, we go to 0 high, which is 3. Away from our axis of symmetry, back to our axis, 3 low, away from our axis of symmetry, back to the axis, 3 high, back to the axis, and 3 low. Okay, let's get this in here a little bit better, and we can get our graph getting drawn here, starting on the axis, coming up. And as we go through, perhaps that could be a better drawn thing, but we're still looking at the idea that we have our domain again. Keep in mind it's -infinity to infinity. Our range, gosh, 1, 2, 3, 4, 5, 6, -6 to 0. Okay, here for our function and our axis. This is our axis here, y equals -6, and we shifted left. Okay, this is our shift left. Pi over 4. Okay, that's our shift left. That's why we started there. So keep that in mind. Those are the things we've got going. We were supposed to find those things, and I've got them listed in our problem. Now, for the same reasons that we are able to ding around with sine being odd, or similar regions, I should say, not the same because cosine's even, we're going to revisit this idea of even and oddness with this cosine with -2 here. First thing, rewrite it factoring out that 2. Okay, so we've got it rewritten, factored out the 2. Remember, -2x, negative, that's positive, pi over 2 plus 2. No, so we just factored that out. We have a -b. And again, as a reminder, cosine is an even function. Cosine -x is equal to cosine of x. Well, if I rewrite it with this in mind, keep in mind that negative drops away like it was never there and is only with the b value. Okay, it's only with the b value that we're making these changes. We've done our stuff with a. A does the flip if it's negative. with the b value, when it's a sine function, the negative goes to the a value out front, and when it's a cosine function, the negative just gets dropped away because it's an even function. Okay, now we've got this information here, and first thing we're going to do is get our a, which is 4, get our b, which is 2, check our period, which is 2 pi divided by b, which is pi. Hey, divide that by 4, pi over 4. And now that's our separation for our critical pieces. So now our 5 critical points. Somebody just can't spell right now. Okay, we got our 5 critical points going on, and let's find where they're at. So I'm going to use green again, like we did before. And I've got 0 less than or equal to x minus pi over 2 less than or equal to pi. Remember, 2 pi is the normal length of our period, and we now know that it's going to be pi, and that's what happens when we divide here. So we got 0 less than or equal to x minus pi over 2 less than or equal to pi. Now I'm going to add pi over 2, so I got pi over 2 less than or equal to x, and this is pi over 2, that's 2 pi over 2, so it's 3 pi over 2 is where we're going to end. So I'm starting at pi over 2. I'm going to go to 3 pi over 4 pi, okay, which is 4 pi over 4. Now I got 5 pi over 4, and I got 6 pi over 4, which is, guess what, 3 pi over 2. Okay, so we got our 5 critical values separated by pi over 4. And we're going to separate this grid up again, very similar to the last one that we just did. Negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2. Okay, now we got that grid down. We're going to look back at our problem, and I'm going to grab a arrow here. Hopefully I'll grab an arrow. And I have that it's going to be up to, and I've got that shift to the right, pi over 2. So we're going to start at pi over 2. So keep in mind as we're looking at this, the things that are going on. I've got a right, let's get rid of that. I've got a right shift, or shift right pi over 2 units. Okay, and I got a shift up, maybe perhaps it'd be better to put this down here, and I got a shift up 2 units. So I'm up 2 units. I'm right pi over 2 units. Okay, so I'm going to get green, and I'm going to start with my pi over 2, and keep in mind I'm doing cosine, so it's chala. I'm just going to write it in there, just remind me, it starts high, it goes to the axis, it goes low, back to the axis, and ends high. So that's my chala. Okay, and I start at pi over 2, and I have 4 being my graph, so it's 1, 2, 3, 4. I just get it in there for my high, and I go back to the axis. I go low, 2, 3, 4. I go back up to the axis, and I go high again here. And then I'm going to fill out the remainder here. I'm going back to the axis, and I go low, and I'm back up to my axis. So as I go through and I sketch in my graph, and let's try that a little bit easier on this. Let's try it again as I sketch through the graph. And we finish out the cosine curve. Remember, the domain is negative infinity to infinity, and the range our range, what did our range go from? From -2 to +6. Let's get that drawn out a little bit better there so you guys can see where that is. And I believe we got it. Then we were supposed to find the range and graph each of the following. We got our amplitude, we got our phase shift, we got everything else. So that's what we've got. And now we've got example 10, A, B, and C. So let's look at those. We're going to use the ideas that we just did, and we're going to look at example 10. I'd really like it if you could actually try to write them on your own before you see me do the solution, just to see where your understanding of this is. Okay? So turn off the video and give it a try. Okay, welcome back. I hope it was successful, or hope you feel successful about it. And remember, when we do these things, if you've got questions, you got to make sure you ask them in class, or during our work time, if there's a work time, or before and after school during those sessions as well. Now, determine amplitude, period, phase shift, vertical shift, and range of each sine function graph. Then write an equation. Okay, so first of all, this is a sine graph. They kind of gave it away to us. Okay, it's a sine graph. So if I'm going to use sine, I either got this back here or this here as I go, okay? But this would be a negative sign. This would be a positive sign. So I'm going to say that this is going up by pi over 4s. Okay, that's 0. This is negative pi over 4. This is pi over 4. This is 3 pi over 4. And this is pi. Now remember, I start here and I go here. Now I've got a period of pi, okay, because I go at axis high, axis low, axis, and it's 1, 2, 3, 4, 5. So my period happens to be pi here. Okay, that's what I just determined. Okay, I could also determine that from crest to crest here if I wanted to, but I'm really looking at that period. Now, since that is, period is 2 pi over b, I know now that pi is equal to 2 pi over b, so b's got to be 2. So I've just determined that b is 2. Okay, a is my amplitude, and I'm learning right now that my x-axis here is my axis of symmetry. Okay, so my x-axis is my axis of symmetry because it's evenly in between the two values of high and low. So I've got a low at -2, I got a high at +2. So my amplitude is 2. Okay, here. And with those things I've got going, and knowing that I've got a phase shift to the left, pi, and I've got 0 and 0 for my h. I'm not even go with 0 and 0 in my h. Let's see what we got here. Okay, I've got a cosine written, but really it's pi over 4, and that's what's 2x. But I've got a y equals 2 sine of 2 times x plus pi over 4. Okay, now remember our relationship of sine and cosine. If I just finish this out, 2x plus pi over 2. I can write this as cosine of 2x because it starts high here, goes low, and it's still 2x. So the phase would be, amplitude would be 2, b would be 2. Okay, so it'd be 2 cosine 2x for cosine. But when we're looking at it, you've got a phase shift, remember, left, that pi over 4, okay? And that's what that's going on. Remember the relationship between sine and cosine and how we get from one graph to another. And that's kind of a neat little extra there as we go through. Just go ahead and graph with that with your graphing calculator. Check them out. I know where you're supposed to find sine. That's why I did these. But either one of these would be acceptable for your sine answer. And then y equals 2 cosine 2x is another possible answer if it was just a sinusoid. Now this next one we get to choose. But now let's look at some symptoms. First, this is looking like my axis because my high is 3. My low is -3. Okay, and I'm starting on the axis. It looks like I flipped it. So I'm going axis low, axis high, axis. I go to pi, so it looks like my B, my period is pi again, so now my B is 2 because of that. Remember, why I can do that is that my period is equal to 2 pi over B, and since I know my period is pi, that's 2 pi over B, I can solve and find out that B is 2. Okay, so that's where I get that. Now, if B is 2, and A is 3, and it's negative 3, when we surmised that it was negative because of the flip, so the absolute value, I should say it this way, that A is 3, and I do a flip on this. Okay, so now I should be able to write this as y equals negative 3 sine of 2x. Now, keep in mind, there is no phase shift, there's no k up or down or h left or right on this graph, and that's where I'm going, so I'm going to color in and say it's C. Okay, and this last one, okay, again, this is interesting because I don't have any pi's here. It's 1, it's 2, it's 3. So I must have pi divided out. So that means pi is B. Okay, and again, this is having my axis is my x-axis, my axis of symmetry here. So I go 1, 2, 3, 4, 5. So I got A is 5. Okay, my B is looking like pi. You know, I've got my period is 2, and keep in mind if my period is 2, and period is equal to 2 pi over B, well, B, if my period is 2, B must be pi. So that's where that comes from. Okay, so now I'm looking at this, and I've got y equals 5 sine of pi x as I go through, and I'm looking at A as I finish this out. So those are the things I've got going, and that is the end of day 3, and we have 2 modeling problems to look at for our day 4 notes. Okay, thanks guys. I hope everything's going well, and have a great day.